everyone, we will talk all about friction problem. So the problem is, a wooden pallet carrying a load of 600 kg rests on a wooden floor. A forklift driver decides to push it without lifting it. What forces be applied to just get the pallet moving? So first, we will draw the free body diagram. So this is the wooden pallet. And the next thing to do is to draw the forces acting upon the wooden pallet. So there would be four forces. First is the downward pull of Earth's gravity, which is the weight. Next is the normal force of the floor pushing up. So normal force. Next is the forward push of the forklift driver. And the last force is the backward resistance of friction. So since the wooden pallet is not moving yet, we can say that the friction is static. So Fs. Then we will equate all the forces acting along the axis. So for the x-axis, summation of the forces along the x-axis, the forward push of the forklift driver minus the static friction is equal to 0. Then, along the y-axis, the normal force minus the weight is equal to 0. So as you can see along the y-axis, we can say that the normal force is equal to weight. Then according to the problem, the question is what force must be applied to just get the pallet moving? To get the pallet started, the driver must push it with a force equal to the maximum static friction. So the equation for the static friction is Fs is equal to mu s times n. And according to the problem, the ms is equal to 0.28. So let's just substitute. So ms is equal to 0.28. So we can say that the normal force here is weight. So we will replace it to Fs is equal to ms times weight. So weight is equal to mass times gravity. So the mass of the wooden pallet is 600 kg. And the gravity is 9.8 meter per second squared. So now we will calculate it. So after calculating it, we can now get the answer, which is 1,646 N. So the force needed to be applied on the wooden pallet for it to move is 1,646 N. So thank you for listening.